depending on the video and the textbook. I think this textbook goes AC. Do you get an A bar? And I believe I've also seen an A with a little dash. They're the most common notations. So which one?
And
that one I know about.
The A bar was the one that was used in all of the other guys' videos that you posted. So I was so lost, but I think that
you just set your brain. When I see that, I pretend it says that.
And I figured that out really late last night. I was like, wait a minute, that is the same thing.
Yeah.
So I just want to make sure. So when I see the AC versus all the work I did with the A with the line over it, that means the same thing.
Yeah, exactly the same thing. It means the complementary event of A. And the idea of complementary is easy.
The complementary event is always going to be the inverse, right? So if you have 1/6, it's 5/6 is the complementary. Yeah. That never changes, right?
Yeah, and the reason it doesn't change is that the complementary event is everything that's not A. So if A has a 1 in 6 chance of making it not A, right, the complement, is going to be 5 out of 6. If it's 1 millionth, I'm not doing the next one, but whatever you get when you take a millionth away, you're 999,999 millionths, right? So that's essentially it. Do we have a question to go with that, or do you want me just to go over the idea?
Yeah, I do. I do have a question. I'll do one that was really confusing just in general, and it was number 13. And I think that my problem was I was not transitioning the percentages, or there was something that they're telling me that I'm not quite getting. So that's basically where I was like, okay, I'm done. I'm making myself more confused. So if you can kind of show me how to break those percentages into, like when I'm writing it down, when I'm putting it together, so that way it makes a little more sense to me, that would be amazing.
Well, here's the first rule you should always try and work with. The typically two different ways in which you're going to deal with. You're going to do proportions sometimes, and you're going to deal with percentages. And proportions is just another way of saying that they want the answer to be a fraction, like 1/10, or they want a decimal, you know, whatever it might be. And percentages is more obvious. Typically, when you do any calculations, it's better to work with decimals or fractions, and only worry about the answer if they want it to be a percentage when you're finished. Because, well, I'll give you a simple example. If I multiplied two fractions together, you would get a quarter, right? But if I take 25% and I try and multiply it by 25%, do you see that that just goes way weird numbers and it doesn't work? Because 25 times 25 is what I think, 625, and you know that's wrong. And so avoid doing the calculation part with percentages. So even if the question says 25% of the people were boys or something, you will use 0.25 in any calculations that involve them. So that would be the first kind of advice I would give you. So let's look at 13. Are you in my first or second class?
I think it's the first. I don't know. I don't know how to answer that. I
am about to tell you that. Right. So let's find out, Tara, and you can remember for the next time.
I know it's 7562, if that helps any.
That helps perfectly, because that makes you the first class. Okay. So if you can just remember that you're the 6-2, that's plenty. That's good. Okay, so I'm going to, I believe it's 7 intro to probability A. Agreed?
Yeah.
And I'm clicking on that one. I'll put it on the screen in a few moments just to double check. Well, it's pretty obvious it's blank, so that's a good sign. Let me put it here. Put that somewhere out the road. And let's do a quick screen share just to show you. And you tell me if this is the guy that you're, where the heck are you? Is this the guy?
Yes, that's the guy.
Right. Now, when you do questions that are kind of involving two different things, in this case, voting is Republican, and the other thing is voted for candidate X, you're almost always going to end up having to deal with what's called a probability tree. They're the best way to deal with two interconnecting situations, especially when they have things like, well, of the 32% of Republicans who we asked, 12% of them voted for this other guy. You know, those kind of questions where one thing then follows to the other. So although you can't see it, I'm going to create the tree diagram and just tell you what's going on. Right. So A is going to be that you vote Republican. The complement of A then is that you don't vote Republican. Now we can get that answer pretty quickly because they told us 63% voted Republican, right? So A is 63%. Right, that's a probability of at least.
Yeah.
And not Republicans. In this case, you could probably avoid turning it into decimal because in this case, it's pretty easy. It's 37%. Right? So I'm now going to create my tree diagram. Event B is that you voted for some guy called candidate X. Okay. So what do we know? The first thing is that you're either a Republican or, I'm putting an A there. I guess I could. And you're not a Republican. And the Republican is 0.63. Notice I'm in decimals now. And the other guy is 0.37. So far, so good. Right, now it gets a bit messy. We're going to look at just Republicans. And Republicans either can vote for candidate X or not vote for candidate X, right? That's their choices. And when I read the story, of the Republicans, 70% voted for him. So 70% goes here. And the ones that don't vote for him, the other 30% goes there. Do you see? You tell me the 70 and I get the 30 for free. So, right? Of the Republicans, right? 70% voted for him, 30% did not vote for X. Are you okay with that step?
Yes.
Right, let's move on to the not Republican people. Well, they have the same choices. They can vote for candidate X, or they can choose not to vote for candidate X. And as I read through their information, of the non-Republicans, that's these people, 15% voted for candidate X. So what about the guys that go down here?
Isn't that what's left of the 37 then when you take 15 off of it?
Okay, so you take 15 off of it, I believe you get 0.85. And you notice it's these two that add up to 1, right? So if this is 70, that's 30. If this is 15, that's 85.
So you go 0.37 and then minus the 15, right?
No, the 0.37 just takes you to here. So the 63 and the 37, that's the two splits.
Yeah.
Right.
So I have the 37, so I'm just doing the voted and not voted, and it says the 15%. So that obviously I put that in the X candidate. And then the not X is what's left of the 37%, right?
It's what's left of the 15%. It's 85.
You have a whole different one that you're working off of.
Yes. You see this pair? You're told this is 15. What's left over? The other 85.
Okay.
I'm covering this up because it don't matter. If we go up here, can you see it happening?
That I think was one of my biggest problems. I was doing it based off of that I only had 37%. So I did it like 15 of 37%, and then I carried down the not X as being that 22. And I was like,
if you think about trying to do that, you can see in the top one it won't really work. Because how could you take 0.7 away from 63?
That one still ended up being 100%. Yeah, that was what I did. That was my biggest issue yesterday.
So what we're now going to
less
do,
stuff than I did.
well, that's better. I mean, you've noticed a little mistake that you fixed. Now, what we're going to do is at the end, you always calculate these 4 events. Now, each one of these is slightly different from the other 3. For instance, see this top event? That represents a Republican who then went on to vote for candidate X. This second
You
one,
multiply them the same as
Yeah.
you would if they were fractions and stuff, right?
Yep.
Anytime you're doing those.
Yep. So I'm going to do a 63 times a 0.7, and the answer I get for this one is 0.441. So about 44% of the time that would happen, right, in total now. Now, if you multiply these two together to get the second one, it's 0.63 times 0.3, and that ends up being 0.189. Now, just so we don't go any further here for a minute, do you notice that those 2 answers that I've just written down do not add up to 1?
Yeah.
There's no reason in the world they should, right? Right, let's do the next one. 37 and 15. So 0.37 times 0.15. That comes out to be 0.0555. And lastly, these 2 guys, 0.37 times 0.85. That ends up being
3140.
3145, I make it.
Make it 45. Oh, you're right. I wrote it wrong out of my calculator.
Okay, now, once this whole thing is kind of fixed, we can then go and start answering the various questions. Some of the answers will come from this table. Other answers we'll already know because they're in the information. So for instance, what's the probability that you have A, which is basically what's the probability that you're a Republican, right? You voted Republican. And the answer to that was simply just 63%. Now, what's the probability of the complement of A?
That's going to be that 37, right? 37.
Correct. Now, do you notice, I guess I could have got the first answer from there and the second answer from there, or I could have just, got it from up here if I wanted to. Now, the next fella is called a conditional probability. What's the probability of B given A? So let's put that into, what's the probability that you voted for X, candidate X, right, given that you were a Republican? Well, the chances that you voted for candidate X, given that you're a Republican, is only that number there.
Or the 70, right?
The 70, right? And what's the probability that you voted for B, given that it was a complement of A? So that would be, what's the probability that you voted for X, given that you were not a Republican? And if you did that one, won't it be 0.15? And those 4 answers you could have got without needing this tree. I mean, you could have probably worked it out without them, right? But it's helpful to have it, especially when they come to the next bunch of questions. Because the next bunch of questions, question B, asks us for the probability of A and B. So that would be the probability that you're a Republican and you voted for candidate X. Now, on my tree diagram, the people who are Republican who then voted X, do you see they end up being this guy here?
Oh, okay.
Now, you could multiply them together, but since I've already done that, why don't I just write down the number? And there's one of those, right, what that represents, and it represents the probability of being a Republican and voting for candidate X, which is essentially that phrase. In my one, I believe it's the 4th top.
Yeah.
Right, now let's move on to C then. C is asking for the probability of the complement of C and B. When you see these ands, aren't you going to think of something times something? So on my tree diagram, I just need to find out who this guy and this guy is. So if I can vert it into a little bit more like this. So it's complement. So you're not Republican and you voted for candidate X. Well, if you're not a Republican, which is this one, right? And you voted for candidate X, which is this one, don't you multiply these two together? And we've already done that. So the answer is 0.0555. And that's how we got that one. Are we good? Now, do you notice that you couldn't really do these questions without this tree diagram?
Yeah, that was what I was having a hard time with, was because it gave me the percentages and then I converted them to decimal, but then it was like putting them together. But I think it was, like I said, I just wasn't thinking about when you make the next branches, they have to make 100.
Right,
So
and so you're basically every
branches,
branch you're starting from scratch, right? So every time you have a branch, if something's 0.2, the other piece of the branch is 0.8.
So then you only needed one side of it to be able to figure out what the complement was. I was just having a hard time.
You have nailed it, Tara. I think you're getting this guy. I feel you know what you're doing.
Yes, I feel like I've got that a lot better.
Now, it says use the results in part B and C, which is these two, to find the probability of B. So probability B is the probability, right, that you voted for candidate X. Well, if I look at my little choices here, isn't voting for candidate X up here? And isn't this one that I'm pointing at also a situation where you voted for X? So that's these two numbers.
Yeah.
So what do you think I'm going to do then to get this combined probability?
Multiply them together?
Not this time. There's not an and in sight, isn't it? It's just B on its own.
Ooh, it's just, yeah, it doesn't say and, it says.
Right, so would you, yes, you add them together. And so you'll go 0.441 add 0.0555. So if you ever see the word and, there's a good chance you're going to be multiplying something times something else, you know, that kind of thing. And if you see the word or just no word at all, like the probability of B as we have here, the chances are it's going to be a single answer that you already know, or at least some answers that will be added together to give you something that you know. And you're allowed to add them because they're mutually exclusive. You were saying, Tara?
That makes way more sense too. I understood what he was saying in the videos, and when he was doing the videos, I was right there of when to add and when to multiply. But yeah, I think that was some of it was just switching. I just switched them around a little bit. So when you see the and, that is that initiates that you're gonna have to multiply.
And just for completeness sake, the only question that they actually even mention percentage is E. And in question E, they say use the result from D, this answer, to write down the percentage of people who voted for candidate X. Well, that's the proportion of people, the probability that they voted for X. As a percentage, it's what, 49.65%. Right? Now, they didn't ask this, but I think it would have been cool if they'd asked one more question. Did candidate X, if this was the final election, did candidate X actually win the election? He got 49.65% of the vote, right? And I'll make an assumption. There's only two candidates, right? There's candidate X and candidate Y, right? We'll assume they're just two candidates.
At this point, wouldn't they do a recount?
Well, they may do in practical purposes, but let's say all the recounts have happened and it still ended up the same, right? Just to make my question easier.
Okay.
Wouldn't the other guy, who's the complement of that, Wouldn't he win?